And then we will what we will do today is we will from now onwards we will implement the actual models which we have already learned, right? So when we just a moment. Yeah. So till now what we have learned like linear regression and I think I forgot to start the recording. Okay. Okay, guys, can you please just wait for 2 more minutes? Let me set up this first. Hello, guys. Am I audible now clearly?
Yes.
Okay. So today, I think you might not be able to access the chat box, but what you can do is you can just unmute in between and ask your queries. Okay. So let me start the recording and we will start. All right. Just tell me once you're, yeah, now the recording has started. Okay. So what we will do today, we will see all the models, like not all the models, we will see one by one model every day, which we have already studied, right? We already have studied linear regression, then logistic regression, random forest, right? Not random forest, decision trees. Okay? And we will also learn random forest, and that from now onwards what we will do is we will start implementing those models, okay, which we have already learned like how they work, and now we know that, but how to code them or how to use through programming language, we will see that today. Okay. So today it's totally hands-on session. It's gonna be hands-on session. So please bring your notebook open and get ready with your notebooks. And I will be sharing one link with you all, which you have from where you have to download the CSV file. Okay, so that we will be using today. And from there, what you can do is you can follow up with me side by side. So we will gonna see one end-to-end project. Okay, a small kind of project. Okay, so you can perform it with me on side by side. So let me first share that link. I will share it on the um, group. Okay, WhatsApp group. uh, I think because in the like in this session you will not be able to uh, download the CSV file. I'm sorry, 1 minute. Yeah, where is this? uh, so so you can check the WhatsApp group, and there I have shared one link, which is a drive link, Google Drive link. From there you can download the CSV file. Okay, so once you have downloaded the CSV file on your computer, and your notebook is ready, then please tell me so we can move further, because that is a proper data set I have found. So we like it would be better and easier to follow up with me. Okay, so let's get your laptops ready with CSV file and notebook open, so we can start coding from there. Okay, just unmute and tell me once you are ready. Till that time, I will create a new notebook. Let's name it. Today we will gonna be see a linear regression model. Okay, a linear regression model in work, like how it works. Linear regression. That's it. I have it on my computer, so I will just copy paste it. Okay, so this is the data set. It looks quite kind of weird. Like you can see, this is how a data set, like we see in the table, right, is stored like this. Okay, a simple text. Okay, but it follows certain rules like commas and all to separate the values. Okay, to separate the data. So what we are going to do is, sorry, let's get this out. Okay, we will upload the CSV file here. Okay, so let's bring the CSV file in our collab environment. Okay, so like you can unmute and tell. Okay, I would be waiting for you guys. So just let me know when you have downloaded the data set, and you can upload it here. Like you can right click and upload, or you can just drag it up here. So today I think the participations are late, and sorry, the participants are low, only 14. All right. Uh, Whoever is like, if you are not doing now, then only if you are not following up with me right now, and if you want to try it out later, then just tell me to move on, so I can just start. Or if someone is doing it with me, then just download that data set, and we will start coding. Okay, and if you are facing any issues like while downloading, then please let me know, because I have not checked. It shouldn't be causing any problem. Yeah, I can see one thumbs up. If you all guys are ready, then put a thumbs up, then I can understand. Yeah, there are lots of thumbs up, so now we can move on. Okay, all right. uh, so I have loaded the data set here. Okay, you can see customer, e-commerce customers, right? So what we will do today is, like as we know, let's start with like data. Like what the normal approach for any problem to solve is, first describe the problem. Okay, so today what type of problem we are solving is, let's just discuss about that first. So what kind of problem we are gonna be solving today? Okay, so just hypothetical situation. Okay, not hypothetical, it would be data would be hypothetical, like it would be fake data. Okay, obviously. And what we will be doing is we will create a scenario of real life scenario where we will try to implement our machine learning models. Okay, the linear regression model specifically. So just let's just consider that we have some e-commerce website, okay, which sells clothes. Okay, we have an e-commerce website which sells clothes, and we have our shops as well, our online website as well, and our mobile applications as well. So we are present at three different platforms: on mobile phones, on websites. Okay, we have websites, and we also have stores. Okay, so let's just consider that uh, we are selling clothes, and we want to know that how we can increase our sales, or how we can increase our increasing the sales is a very broad area. Okay, so there can be many factors to increase the sales or which affect the sales, but we will define a specific task for this model, or a specific problem, very specific. Okay, so what we are trying to do today will be, we will just consider let's say, um, let me use this. Then what we'll be using is, what we are trying to do is, we will be finding some relation. Okay, as I mentioned that we have website as well, and we have application as well, mobile application, right? So we just want to know that which is giving us more result, okay, better result, which is helping our business grow. Okay, so if website is like okay helping us in the business, like it is bringing more revenue, more part of revenue, then what we will be doing, like we will then find uh, a better application presence, right? Because we want to reach to the people through all the ways, through website as well, through mobile applications as well. So we are just wanting to know that how we are performing, and how can we increase our performance by customer experience. Okay, so just let's consider that and this is our website. Okay, and this is a mobile application. Okay, let's just consider it as two box. Okay, so we both have two things. Okay, and here is our main business. Okay, uh, let me write business, web application, and app. Okay, I hope it's visible. Okay, so this is our main business. Okay, and we have two platforms. Okay, we will not consider a physical store now. Okay, just for simplicity, we have one website and one application. So we want to know that how um, users, like how you customers are behaving, okay, in our on our platforms, and how we can increase our what we can say, sales, not sales, how we can increase our their time spent. Okay, how much time they spend on our website, how much time they spend on our application, how much money they spend. Okay, we have those data. We will see that data as well, how much time they spend on website, how much time they spend on application, and how their time of spending is related to the amount they spend on our brand. Okay, so we will see all those relations. Okay, so I think it would be more clear when we will see the data itself. Okay, so as I mentioned, we have uploaded the data. Let's just see and explore the data, like what we have. Okay, so as, till now you should be clear with the goal of. Okay, so what we are trying to do is, we are trying to figure out how the time spent on the web and time spent on the application are affecting our business. Okay, and how it is affecting to the money the customers are spending. Okay, so basically our sales, it's basically our sales, right? But in terms of how much amount they are spending, okay, on our site, uh, and how that is related to the time they spend over on our apps, how they spend time on our website, and all other things that are related, like from how long or since how long they are being a part of our membership or anything related. Okay, so we will like the main motto is we have a question. Okay, we want to increase the customer experience, so we will try to increase the interface. Okay, so how they are we can understand that if they are spending low time, then we should try to increase the amount of time they spend on our website, so they can look for more products, and like it increases the possibility of buying few more products, right? So our main very specific question is which platform should we work on. Okay, we want to increase our sales, right? That is a broad term, but a broad term, but that is at the outcome. But what we are trying to do is we are trying to increase, or we are trying to figure out that where our efforts should go, like in improving a website or in improving the mobile application. Okay, that is the very specific question. Okay, so uh, on where should we spend our efforts, on mobile application or on website, which will lead to customer experience, which will again lead to the amount of time they spend on our website or application, and that will lead to the amount of money they spend. Okay, and that will lead to the ultimate goal of increasing the sales. Okay, so we are not just targeting that we want to increase the sales, but we are like cutting that problem into very specific thing, which we where we can use our machine learning problem. Okay, so when we use a very broad term, right, like cells. Okay, so it contains like it is being affected by a lots of different measures. Okay, so at starting point, like as we are just starting with the machine learning, okay, problems, so we just do not directly dive deep into that. Okay, we specify very specific problems, and then we try to figure out the relations and how they're affecting, and um, how can we benefit from knowing that what is the relation of the all of the things, like spending time on on apps, and how much spending they are how much money they are spending and how much time they are spending. Okay, so we are like finding out very specific problems. Okay, so machine learning, that is a like first thing we should consider, that we do not like ask direct general questions to machine learning problems. We do not ask like how I can increase my sales. We ask, if I am doing this, will that cause any increase in sales, like overall revenue? So that kind of thing, like questions we a machine learning engineer or practitioner should ask, like very specific question. Is something is causing any difference, or is something very specific can cause anything? So we find those type of questions and try to solve those type of questions. Okay, so we do not the first point to note is we do not ask general questions, like how can we can I do this, or how can I do that. We divide those problems into sub problems and find a very specific question. Okay, and then try to apply the machine learning problem on that case, and then we just propagate the results. So as we can know that if the amount of time is changed, and it is that affecting the time customer spend sorry, the user interface is affecting the time customers spend, and it then affects the amount of money they spend, and then like we propagate. Okay, so we start with very specific problem, or we start with a broad problem and come to the very specific problem, then apply our models and algorithms and all. Okay, and then try to use its result and propagate the result to solve the bigger problem, which is of cells. Okay, so that's how we should, and all the machine learning practitioners do, like specify very specific problem which a machine learning algorithm can perform or solve it. Okay, so let's start with data. Okay, so as till now you should be clear with the goal. Okay, what the machine learning model today will solve the question. Which question will it solve? Okay, is there any regarding how to think of a problem and what problem we are gonna solve today? So is it clear? Is there any doubt, like in questioning, like how to formulate a machine learning questions? Okay, machine learning cannot be applied everywhere. Okay, there should be a specific scenarios where the data is available, main question, and then the problem should be very specific. Okay, then we can propagate the result and again try to iterate that. Okay, but is it clear, like how we think of problem and what is the problem we are going to solve today? our problem for today is, should we spend our efforts on developing or increasing the user experience on website, or should we focus our efforts on increasing user experience on mobile application? So that's the main question we are gonna try to solve today. Okay, where to spend our efforts, on mobile application or on web application? Okay, is the question is the problem definition clear? It should be the first point to. Okay, so if you are not very clear with the problem statement, then you shouldn't go further. Okay, so is it clear till now? Is there any doubt till now? If you have any doubt, like just unmute yourself, because the chat section will be not active today. We are using Teams today. Okay, so if you have any questions till now, then please unmute and ask. I will wait for 20 seconds. Okay.
No, it is clear.
Okay, all right.
How do we get the data into the coding?
Yeah, sure. We will see that how we can get the data into the coding, right? Your question is, as I already shared the link, okay, on the WhatsApp group. From there, you can download the data set. Okay. Now, how can we get those data set? That is a different question. But how we use this data, available data, into the coding is a different thing. Okay. So I think your question is how to use this data into coding part, right? How to use in while coding. Am I right? Is that your question?
Yes.
Okay, we will see how we are going to use this e-commerce data. Okay, so let's start with it. If you, I think you might have missed some parts of the this series. Okay, and this ML bootcamp, you can refer them on GDSC AUM channel on YouTube. All the sessions are available there, and you can find the pandas session there. Okay, so I think it was on day 7th or 8th. You can find that, and where at that point I have explained everything in detail, how to use this data set and how to explore. But we are going to do that same thing, not all the things, but we will do the required things today to make our model. Okay, and solve the actual problem, which is gonna be where to focus our efforts, on mobile application or web application. So let's start with first importing the required things. Okay, so like you can get this data sets. Okay, there are like lots of data sets available, and today we are going to be using this data sets, which is already predefined. Okay, we just need to explore it, understand it, and then try to formulate the model and use it to solve our problem. Okay, so that would be our approach. So first of all, we have data. So what we use to deal with the data? Okay, we have CSV file. We have seen the pandas library, right, where we I'm sorry if anyone is new, then please you can refer those tutorials on previous sessions. Okay, all sessions are uploaded on AUM channel on YouTube. Okay, so because we are just going to be using the required things, and I might not go into very much details, because I have already explained what pandas is, how we can do that and all. Okay, how we can use it and all. So today we will start like what we have in hand. Okay, we have in hand today data set. Okay, so first let's explore the data set and try to understand what is the data set available with us. Okay, so for dealing with data sets, we know that it is a CSV file. So what we use for the CSV file and data exploration? Pandas. Okay, so let's import the pandas. Okay, you can import the pandas as import pandas as and okay, so that's our first requirement, because we have this pandas library, sorry, data frame. Okay, so we can read this data set, available data set, using pandas pd. We will refer pandas as pd dot let's say data frame, sorry, the read csv, read underscore csv, and then what we will do, we will specify just the name of this file. Okay, we know that it is a csv file, so we will just specify the name, its name, so it would be directly accessing that file. The answer to that someone's query is, we can read that csv file into code by using this code, read csv method. Okay, for that you have to import pandas. Okay, so let's do that quickly. E-commerce customers. So running it, commerce customers, no, that's that. Okay, content.
No, I think a spelling mistake is there.
E-commerce customers. Uh, Now it's fine. Okay. Yeah. So let's just see and explore our data set, like what our data set is doing. Okay, like what we have. Uh, we have in the columns we have emails of customer. Okay, we have address, we have avatar, like profile pictures. Okay, then average session time, and time on application. We, as we discussed, we have application as well as website as well. Okay, so time on website, we have those data, and then we have length of membership. Okay, how much, like since when they are a member, prime member or something, with the brand or company. Okay, uh, and yearly amount spent. Okay, so how much money they are spending on our platform. So we have this much data. Okay, email address, avatar, average session length, time on app, time on website, length of membership, and yearly amount spent. So our main motto is to increase this, right? Like increase sales on in broader terms, and you can like come down to the specification, and we can come down to the how much amount they spend yearly. Okay, so this is our main motto to find out, and accordingly for that to increase this, that we have this other data. Okay, which will be helpful to find this, to find how the amount spent by them is related to other this type, like how they are related to time spent on app and time spent on website and all. Okay, and how much, um, like since when they are a membership of. Okay, they are our members. Just a moment. Yeah. So then now what we will be doing is, let's just save this data. Okay, we have read this CSV file, but to refer it and again, to use it again and again, we have to save it somewhere. Okay, so let's just create a variable data and read CSV. Okay, so now we can refer that same data using the data variable. Okay, so let's see data dot head. Okay, we'll just get a brief of the data. Then yeah, you can see. Then next thing what we will be doing is we will describe the data, like as we can like by seeing this, we can see that how many datas are there. Okay, we can check that out as well. Data, then we have 500 rows and 8 columns. Okay, we can check the same thing using describe method as well. Describe method will describe so many important values about the data. Okay, about this data frame. So we will see that. Okay, uh, yeah, parenthesis data describe. What it does is, it does the overall statistical, it shows us the statistical data about this data frame. So we can see that there are count equals to 500, means there are 500 values in every column. Okay, in every column there are 500 values, means we have data of 500 people. Then the mean of all the columns. Okay, just remember that it is it only shows the numerical values. Okay, so as you might also like, it would be like more common sense that these things doesn't matter, right? How much time we spend, like if someone's address is different, maybe might it be like related that in some countries or in some cities people spend more amount of time. But today we will just stick to the numerical data and try to find this relationship shifts. Okay, with time and their membership and their spending amount. Okay, and try to find the, like where do we need to work on app, either app or either website. So our motto is where to work, where to focus our efforts. So let's just do not consider, like let's we will not consider this addresses today. Okay, so we can see that uh, in most of the cases addresses are like, if two neighbors have the same address, only very one or only just a difference of one number, okay, the house number, then it is not necessary that the spending uh, pattern of both the neighbors would be same, right? So like generally the address doesn't matter actually, how much spend, like people can be of different, we cannot directly predict it on the basis of addresses, okay. Address is very irrelevant, we can say, in finding the amount of spend. The city we can consider, okay, on the basis of their cost per capital, or like some similar parameters, okay. So for describing the data set, it shows us all the statistical data of numerical values, okay. So we can see that we have mean of every column, okay. We have standard deviation, then we have minimum values, maximum values, and the average, okay, the median as well. Okay, then next, like we can see, and try to understand that this how these numbers are changing, okay. So you can see that the mean, what we can say, the mean or average length of session of all customer is 33, okay. And on the time, on the app, okay, the average time is about 12 minutes, and on the website the average time is about 37 minutes, right? So like generally we can when the amount is when the data is less, in this case only 500, okay, then it in some cases it's easier to just after seeing we can just give a guess, and it becomes it gives the, we can guess it right, okay. So in some cases we can guess it right, and we for business purpose we just do not trust on guesses, right? We need some actual evidence of this all are mathematics, okay, in the background. So we trust mathematics, okay. So we trust the computations more than just guesses, okay. For business purposes, many times guesses might come true, but we want the mathematical evidence or numerical values for to make those kind of decisions, okay. So and let's see, we have data, right? In the data, okay, we can just change this to like customer. So uh, let's just keep it data, okay. Then data.info, we are just looking out in the data to understand like what kind of data we are having, and what are like to familiarize ourselves with the data, okay. So we can see that all these columns have uh, 500 values, okay. No null, like none null means none of them are empty shells, okay, in the table, in this table, okay. So we do not need any kind of dropping the rows, or like what you can say, filling the rows with average or mean value, okay. As we have discussed this, in this case the data is pretty good. I have found it, and to just get started with models, okay, to implement models. But further, if you want to increase your skills, then you can also make your own data sets as well, and as we have discussed and in previous sessions, and you can try to collect data and all, okay. So that's a another thing. Today we will be focusing on creating an end-to-end product with the help of models, okay. So our main focus would be on models and the actual flow of a machine learning project or a machine learning task, okay. So let's do some data analysis as well. Like now we know that what are columns are there, and what are the ranges of values and minimum and maximum, right? So let's just do some data analysis over it. As we have like seen in previous sessions as well, and we'll see today as well, that when this statistical data are not enough, okay, in many scenarios, okay, this only is helpful for numerical data first, the first point. And other thing is, with statistical data you cannot get much more information as much as the graph shows us, okay. The graphs, those are very helpful in visualizing the data. Like by visualization we can understand many things, okay. So we will use them as well, okay. So we will do the data analysis with the help of C1 library. Now, what is Seaborn? If anyone is new, it's a library to draw graphs, okay, on the basis of data which we are having, okay, in our hands. And if anyone is new, like haven't used Seaborn, or have missed the Seaborn session, previous sessions, then please go to the YouTube channel and you will get it. So you will just get a gist of it today, okay. So we will using C1 to visualize this data. Okay, so let's, before using it, we need to import it, right? As these libraries are not in the core Python. So import C1 as SNS. Okay. And now we can use the C1 to draw graphs. Okay. Then what we have else is we also need matplotlib, right? So because as we have discussed, this Seaborn is was made on top of matplotlib. So we will also use matplotlib. What matplotlib and as pipeline. Okay, so we will use like we will refer this matplotlib as PLT, and we will refer Seaborn as SNS. Okay, so let's just start drawing graphs. Okay, so that the first graph would be let's see join graph. Okay, uh, what we will be doing is we need to find like what is what where we should focus our efforts, right, on app or website. So first what we will do is we will find the relationship, okay, because our ultimate goal is to increase this amount. Okay, so first we will try to see that which one is affecting this one more, okay, or which one is more co-relevant, or what which one is more related, what we can say, uh, which influence this amount the more. Okay, what we have these parameters and what influence this amount. Okay, so we will first find the parameters, so values of parameters, or we can say relationship between these parameters. Okay, these all are parameters, and we will find the relationships between them. So let's say first we will see joint plot between two of the parameters which we are having. So the first parameter is, sorry, data, yeah, data, then the time on website column. Okay, time on website. Then the second one would be data and yearly amount spent, because our like, we want to see how this amount is being affected. Okay, so we will see how we will draw the graph of the data of these two columns, and we will see how these two columns are related. Okay, it will, and the graph will speak much about it, the relation. And then yeah. So the graph will speak much more about the data instead of just values. So you can see that like this is the yearly amount spent, right, in this y-axis, and this is the time on website. So we can see that like it's quite distributive, like very distributive. There is no pattern. Like if they have spent less amount of time, then also they can spend more amount of money. Okay, and if they are like you can see that it is very good, like very distributed data. Okay, in all areas you can see more time on website but less amount yearly spent. Okay, this point, and here less time spent on website but more yearly amount spent, and these are bunch of few other points, data points. Okay, we can refer it as data points. So it is quite distributive in nature. Okay, so let's see similar relationships between different like other parameters as well. So we will use the same graph again. Okay, just copy and paste, and in this time we will see the time spent on app and the yearly amount spent, and like a relationship between the time on app and yearly amount spent. So we will get similar graph, and we can interpret much more things. Okay, so you can see here that more like here there are no like very less data points, right, like a low time on app but high spending. Okay, very like I'm sorry, equal to none. Okay, here as the time grows, the amount also is like amount spent is also increasing. We have those kind of customers. Okay, low time spent, low amount spent. Okay, then we got few like different bunch of like different type of people. Okay, and their behavior. This is showing us the behavior of the time spent on app and the yearly amount spent, their relationship. Okay, so we just are like seeing the data how they are distributed, and this is the distribution. Okay, majority of our spending around 500 okay dollars or rupees anyway, anything, and most of them are spending time nearly 12, or we need to see what's the unit. uh, let's consider just hour. Okay, or minute, no, not minutes, hours. Okay, per day. And then you can see like how the data, how the data points are distributed, how the relationship is distributed. You can see the difference, like here there are more data points and here there are less. So how they how this relationship is there. Okay, so that you can see. And similarly we can see for all the pairs, right, as we have seen it, and these are just between two of the parameters. But if we want to see that what is the relationship between all the parameters, then we have few other type of graphs as well, like pair graphs. Okay, we will use that to see all the relationships, possible relationships. Okay, and we have named pair plot. Okay, then we just need to pass the data set, then it will show all the possible combinations of numerical data and the relationships between all the parameters. So let's see, let it load. And yeah, yeah, we can see that these are like different parameters. Okay, and all the possible relationships. We have 5 parameters and 25 relationships. Okay, so we can see like one by one. If we see, then this is like quite distributive. Okay, it is the data points are distributed like harmoniously, and in this there is some clustering, like more people are inclined like this. Okay, here there is more distribution. Okay, between time on website and yearly amount spent, time on app, and this. Okay, average session time, let sorry, average session length, and that yearly amount spent is quite related like this. Okay, you can just you don't have to get a very specific outcome, okay, from this graph, but you can see like how the data sets are distributed. Okay, how the customers and their behavior are distributed, and how two different parameters are related with each other. I think from here you can understand that with the length of membership and the yearly amount spent. Okay, so they are like quite they are showing some pattern. Okay, some pattern, like as the length of membership increases, the amount of the amount spent yearly also increases, right? So you can get gist from the data through this. Okay, so it is showing like some through this you can conclude like what kind of conclusion or what kind of information from this graphs you can get is, you can get the relationship between two. Okay, like which one is more related to which one. Okay, so and the more there is distribution, okay, of data, the less there is correlation, okay, between that two parameters. So here you can see there are very distributive, okay, the data. Then we can see that there are less they are less correlated. Okay, but here it is showing some kind of relationship. Okay, so we can see that this is, as the length of membership increases, the yearly amount spent also increases. Okay, so there is a certain relationship. Okay, there is some we can see it clearly through the graph that there is relationship between this, and that is like quite linear. Okay, that is quite linear relationship. Okay, and here there is no such relationship. There can be relationship, but not not as we know that this type of relationship is like linear, and here that is not followed. Okay, so here there are no direct relationship, like if the time on website increases, then doesn't necessarily the amount spent increases. Okay, so but here in this case we can see that it is directly proportional. Okay, but like you can just get a gist of the data, okay, and some kind of overview of the relationship, okay. You can get this from this type of data. So what these graphs are showing is all the possible relationships, okay. Let's move on, and from this graph, uh, our main aim was to find the relationship of all parameters with yearly amount spent, right? So through these four graphs, okay, through these four graphs, what we can see is there is like from from these four, okay, only from these four parameters: average session time, time on app, and time on website, and length of membership. The length of membership is very much more correlated with yearly amount spent, right? And all other these parameters are less. I'm not telling not at all, but are less related. Through this graph, we can see that, right? So there is some kind of pattern is there. Okay, and we can see through the graph, we can see that this one is the most correlated parameter with the amount spent by the customers, right? So don't worry about this graph, because it is showing the self relationship with itself, okay. So it is showing just the distribution. The last graph, okay. And next, as we can see, the length of membership is most correlated with yearly amount spent, right? Let's do some more analysis, okay. We have seen linear graph, right? A linear regression graph as well in our C1. Let's draw that. The name was something LM. You don't need to remember. Like if you write this and start writing, then you can see all the graphs, okay, which can be drawn using CNS, sorry, SNS. That is C1. So we will draw this LM plot, okay. LM plot is just a regression plot, okay. So it shows a regression line through the data, okay. So that's see on the x-axis. Now as we have concluded through these graphs that this one is the most correlated, okay. So we will plot that against this yearly amount graph, okay, and find a regression line for that, okay. uh, let's say on x-axis yearly amount spent, what was the name, yeah, and just keep this notations, okay. Like if there is some spelling mistake, then it would be cause time again. Y equals, we have length of membership, okay. All right, and data we have customer, sorry, data we have data only. I'm sorry, one minute. Equals data. All right. Let's see the regression line between this, okay. So if you can see this blue line passing through the data is the regression line, okay, for this data, for the data which are showing the length of membership, okay. So this is not not the customers, okay. This is the data about length of membership, since how long they are they have been member, and their relationship with yearly amount spent, okay. So that is this relation it is showing, and for this relation the best line we can see is this regression line, okay. This one line is passing through the data, so that regression line is basically, as we have already studied, that a best line that passes through the data with least variance, okay, or least distance from the data points, okay. Then I hope that concepts are clear, okay. If there is any doubt or something related to that, you can always unmute and ask, okay. So that's a regression line, okay. We will see now, we will till now we have seen much about data, okay. So now what we will do is we will find the regression model, okay, and which will be able to predict um, the new like when we ask that how it will affect, okay, or which one we should work on, or where we should focus our efforts, right? So now now till now what we have done is just data analysis. Okay, we gone through the data, we try to find the relationship. Okay, so from this data you can like filter out that few parameters are more relevant and few are less. Okay, and like address and names are like not that much related, we do not need them because they do not contribute in behavior of the uh, customer or amount they spend. Okay, so let's now the actual models will start. Yeah, like today also we are running out of time. Okay, we are late. No problem. Like if someone have any important work, then they can refer the session later on YouTube. It would be uploaded after this session. Okay, so now we will actually go and create a actual model. Okay, so first of all, before moving creating the model, what we have data. Okay, as we have learned previously, or let's just revise the data flow. Okay, the working flow of the creating machine learning model. What we need is we need data. Okay, now we need data, we need model. Okay, and then we train it, and then we after training, uh, like the model adopts the data. Okay, and then we again test it. We again test the trained model. Okay, and that was the training fruitful, or how the data how the model is behaving according to our requirements or not. Okay, so we again after training, we again test the that trend model. Okay, and then if it gives the outcome as we required, then we use it like whenever we need, or then we conclude that now our model is ready and now it is ready to use. Okay, so first of all, what we have data now. Okay, so we have to first like as I mentioned, we need data, and we first train, and then we also do the testing of model. Okay, so what we will need is we will need data while training, we will need data while testing as well. Okay, at both stages we need data. And one more thing to remember is the data used at training, used while training, cannot be used again for testing. Why? Because at that time, model will know that what this data is and how that is related, or what the outcome of the data is. Okay, so for that it can easily guess the right answer, but we need to test it. So we will give it some data which were not used while training, so it would be new for it. Okay, and then we will see that does it predict correctly. Okay, it will predict some values. What we will do is we will find that is that predicted value matches our required value, because we will be knowing the required values. Okay, we haven't trained it, but we know it. Okay, we will compare those values. Okay, the predicted values and the original values, which should be the output. Okay, so we will compare them, and we will see that how much the difference is there between predicted and the actual output. Okay, then we will decide on that further, that we should train it again or not. Okay, so the first task would be to split the data into training and testing. Okay, as I mentioned, we cannot use the same data again and again for both the cases. Okay, so what we will do is first we will split the data. Okay, so let's just visualize the data again. Okay, data dot head. Now we have this much data. Okay, so what we are trying to do is we are just trying to find the relationship of all the parameters with this yearly amount spent. Okay, so what we will do is how these parameters are affecting and how much they are influencing this yearly amount. Okay, so in this case, this yearly amount spent becomes our targeted outcome. Okay, so if we tell the model that the session length is 34, the time of on app is 12, and the time on website is 39, and length of membership is 4, then it should give us this value or around this value. Okay, so what we are gonna do is we will first decide what will be the target outcome, like what we are like targeting. Okay, and what would be our input parameters. Okay, so this one is the target output. Okay, why this one is the target output? Because ultimately we need this relation, like we need the influence of all these parameters on this outcome. Okay, on this amount. So that would become our target output, and all these other parameters would be our inputs. Okay, so first we will define that. Okay, as we know that you know that linear regression is simply a line, right? And a line, the equation of line has some independent variable, some dependent variable, right? So y is the dependent variable, which would be the outcome. Okay, because the amount spent is like is dependent on this all these parameters, and we need to find that on which parameter it is depending most and on which parameter it is depending less. Okay, so if we find that on some parameters it is depending less and on some parameter it is depending more. Okay, so accordingly we will take the decisions, like if it is depending more on website, then we should consider this website. Okay, and look for this website, because that data would be more variable for this amount spent, because it is depending on this. Okay, and on the other view, if we say that on the day, if the data the spending time spending amount is not related to the app. Okay, and it is more related to the website, then what we can do is what we can conclude is it is relating like it is depending less on app. Okay, so the time spent on app is not affect yearly amount spent. Okay, or which one is like directly proportional, or which one is showing the correlationship. Okay, so if the app is showing less relation between the amount spent, then what it means is we need to work more on app, because we need customers from through all the platforms. Okay, so what it might show like indicate is the website is more contributing the revenue, the app is less contributing the revenue. Okay, so we need to like increase the revenue from all the streams, right? Because our ultimate goal is to increase the revenue. So we need to make our presence better on all the platforms, and where there is our presence is not good, so we would interested in improving that, so we will focus our efforts on that platform. So all the platforms are like giving us a good amount of customers and revenue. Okay, so that's how we will find first we will find the relationship, we will find how this amount of spend amount is depending on which of these parameters. Then accordingly, which one is related more, and which one is related less. If we found that, then on that we will decide that if it is less related, then what should we do so that it contribute to the amount spent. Okay, so if we found that a website is like contributing more in amount spent, and app is not contributing or very contributing very less, then we will try to improve the app, because from there also we need customers. Okay, so we will try to improve app. Okay, so similarly we have this like you got, I think you got the idea, like how we will be approaching and how we will solve the problem. We will first find the relationship. Okay, then we will find which one is more related, and then on top of that, according to its results, we will find the like we will make a decision like which one to improve. Okay, so for that, as I mentioned, that we need testing and training data sets. Okay, so first we will define that what will be the outcome and what will be the input parameters. So y, let's consider I am naming it y, x, and y. Okay, so y would be the target value, or the target this one outcome. Okay, so let's specify it as, and so we can refer it again. Okay, using y. So I am just assigning y with the target output. Yearly amount. And guys, if you have any doubt, please feel free to unmute and ask now only. Okay, because we are already running out of time, and if the doubt are still remaining, then there is no point of teaching, right? So make sure your doubts are clear. Okay, and here I am specifying all the input parameters into x. Okay, so so that I can refer all the inputs using x. Okay. 9. Let's see now. As we have, like, if you are not familiar, here we are passing a list. Okay, here only one parameter was there. Okay, only one outcome was there, so I just passed the name of that column. Okay, but here I have multiple parameters. Okay, input parameters I have 4, so I will pass the list of all these 4 names. Okay, nothing, no difference, like instead of this 2 bracket square braces, there would be 2 more. Okay, one more pair of square braces. Then I will pass the name of all these um, columns. Okay, what we have: average, session length, then time on app, then we have time on website, and lastly we have length of membership. Okay, membership. Okay, let's define this. Okay, so now we can consider them. Okay, time on website. I just did this spelling mistake. AWS capital. Okay. So now we can refer all the input parameters or all this data. Okay, all these columns or all columns can be accessed using X, and the last column, whole column, okay, can be referred by Y. So now comes the actual new library, actually a new library which will be helpful to create these models. Okay, one thing I would try to address is here is that as we are starting, like as you people not having much experience with machine learning, right? Practical experience, you are just starting out. So the first approach is learn how to make a flow of project. Okay, or complete flow, you get a clear picture of end-to-end product. Okay, like from starting to ending, what to do. Okay, then if you once you get the whole picture, then dive into smaller parts of it. Okay, and then try to master it. Okay, so what we are going to do is, as you are now you have already learned machine learning algorithms, right? You have like learned, or you have already learned how machine learning works, and what is the background theory and what it does in the previous sessions, right? So we what we are going to do is we are going to use that model. Okay, now there are two possible options. Okay, we can create a whole machine learning a whole linear regression model by ourselves. Okay, a whole complete linear regression model by ourselves, which will include much more detailed things. Okay, the theory was not that complicated, but while creating, it uses many details, right? To create from scratch. So it uses statistical methods and all of that. Okay, so what we are going to do today is, first step, we are going to take a whole picture of the project, like end to end, how we proceed with the machine learning task. Okay, with the linear regression, and in this case, today, we will use a linear regression model which is already built. Okay, so we do not need to build it from the scratch. Okay, as I mentioned that there are libraries which have predefined things, as we have seen that pandas and how to handle this data. Okay, how to handle this data, it all taken care by pandas library. Okay, then how to grow this plot, it's all taken care by seaborn. Okay, so similarly, there are like pre-built models. Okay, what we can do is, I think if you remember, I have explained it in one session, that the models are very generic at first. Okay, are very generic at first until they have been fed data. So once we fed the data, then they become specific to that data. Okay, then they become specific and adopt the data. But before that, the model is generic. The same linear regression model can be used to predict, in this case, the customer behavior. Where to the same model can be used to decide where to spend our efforts. The same model can be used to predict the amount of spending amount, okay, yearly spending amount. The same model can be used for different applications. But before training it, all the models, the architecture of model, okay, we will use the architecture word. The architecture of the model, the definition of model remains the same, okay, in all the cases wherever the application is called. Linear regression means the same thing. It can be used in classifying or like predicting house values. It can be used to predict where to spend efforts. It can be used to find out how much amount they spend, okay. So the same thing can be used in different places, because the under the hood, the like the model doesn't change, okay. The model is very generic, can be applied to anywhere until we fed the data. Once we fed the data, it adopts that data, and then we can only predict or use it for the specific task for which we have fed the data. And in this case, we will feed the data for identifying the relationships and deciding where to spend our efforts. So now, after feeding the data, we cannot use it to classify or predict house values. Okay, we need other data. So as I mentioned, that the same thing is used again and again in different applications. What is done is, there is a one scikit-learn library similar to as the pandas library is there as to handle this tables, like Seaborn is there for to handle graphs, okay. This scikit-learn library is was made to take care of the architecture, because they were like uh, all the time they were same, okay. So why to create the same thing again and again, okay. We just directly use that model, and according to our data it will adapt different applications, okay. So it was a generic, as I just mentioned, okay. So it was already pre-built. So we will today we will use the predefined or sorry, not predefined, pre-architectured model, okay, which is linear model, linear regression model, okay. We can create the linear regression model from scratch, but it would require some more detailed explanation, and will require some more detailed study, okay. So today what we will do is, as I mentioned, there is a library named scikit-learn, okay. So we can import that, okay. We can use that library to use the linear regression model, okay. So we will do that, as I mentioned, from learn. The name of the library is learn, but have name convention like sk learn, okay. learn. Then from there we need like this library consists of many things which are useful and which are which were like repeated task, okay. So defining the same architecture again and again for all the applications can be like hectic, okay. If some one person can is working on different projects or want to make different projects, then it uses the same architecture. So why to code again and again? We can code one time and use it again and again, right? So for that there is a library and we can use the model, okay. So there there are certain steps, okay, which you need to like just remember, okay. There is nothing to learn from scikit-learn, this library. You just have to remember that this library contains what type of models, okay. It contains so many models, and what type of methods it contains, okay. So uh, here what we are importing is scikit dot model selection, okay. From here we will import train test split, okay. Like few things might be new, like what is this from? We have seen import, okay, but what is this from? So what it means is like pandas, there is this train test split, okay. Like pandas, this is a library, but this library where it is located, it is located in the parent folder, okay, like this. In actual there are like folders. This is the main folder scikit-learn. Inside that there is another folder model selection, and inside that this one is the method. This one is the collection of methods, okay. Train test split. So we are importing that because this whole folder contains many things, okay. So we do not need all the things, so that's why we will only import the specific one, okay, which we need, the train test split. As I mentioned that we need two data, okay, for testing and training different data. So what we will do is we only have one data set, right? So we will split it in two parts, and then we will use one for training and another one for testing. Okay. So first importing this train test split. So what it does is it does the splitting of the data for us. Okay, so we do not have to worry about that again. So let's specify name. I will first write it and then tell you what I have done. Okay, just a minute. Yeah, extend. Okay, next test by train by test by test split, then summarize, and we also specify test size. I will explain what these parameters are. Okay, just a moment. Okay. Set. Okay. So here there are few things. Okay, just consider this highlighted stuff. Okay, first of all, just consider this highlighted stuff. Uh, we have one method. Okay, train test split, which we have imported here. Right, we just need this method, so we specified it that we only need this method and we will use it. Okay, now what we are doing here is we are passing this x and y. You can see yeah you can see we are passing x and y, right? Hmm. X and y, which are like this, which are the x contains all the input data. Okay, all for these columns. Okay, not just names but all the data in the column. Okay, all these four columns, it can the x contains all the input or input parameters data. Okay, and the y contains the output data. Okay, so what here this method does is it divides the data. Okay, this we seen that we have 500 rows, right? So what it does is it does split, and it splits the data randomly. Like here you can see test size is 0.3. Okay, so now what this test size 0.3 is, if we considered 1 as 100%, then 0.3 means 33% of sorry 30% of the data. Like out of 500 rows, the 30% of those rows should be used for test. Okay, this parameter means that the test size. Okay, we are splitting the data into test and train, so the test side size should be consist of 30%. So if 1%, here we pass the value with between 0 to 1. Okay, so this 0.3 means 30%, or 0.3 out of 1. Okay, so out of 500, 30% of rows should be used for test. Okay, and the remaining 70% should be used for training. Because why this split is actually important here. If we use less sorry less data while training and more data while testing. Okay, so what it goes is it doesn't give a proper or accurate answers, because for training there were less data. Okay, and the best split is around 70/30 or 80/20. Okay, so we use that because for testing we just make to sure that whatever the model has trained till now is has trained correctly or not. Okay, so we as you might know that we have a lot of syllabus, like a lot of chapters. Okay, in the syllabus, but for exam very few questions are asked, right? Because for testing we do not need to consider all the things. Okay, and for training, like uh, like in exam, not in exam actually, because in exam that is the same thing. Here, as much as the training data, much the model learns. Okay, it is directly proportional. The more the data, the more accurate answer the model gives. Okay, so we try to maximize the training data, and at the same time we want some test data as well. So we have like this is the you can use any split, okay, but generally not generally, but better would be more training data and less test data, and you can take the portion proportion according to your choice, okay. And generally most of the time we use 30-70 or 80-20 or 25-75, okay. And then this second parameter is random state, okay. What this random state is, that in this 500 rows you pick randomly, okay. You pick 30% of rows randomly. Do not take all the first 30 or all the last 30, okay. To just maintain the what you can say, if we pick all the time randomly, then it is a high chances that behavior would be same, okay. Not all the exact same, but similar behaviors, right? And if we pick just first 30, and if we pick just last 30, then there would be a much difference between their behaviors, okay. So to maintain the behavior, to keep it similar, we pick random rows, okay, for the test data. So it shouldn't be the it shouldn't be the case that we again if we again train the model, and if we use the same training and test data, then what happened is the outcome would be same. No point of training it again, right? So we randomize it. It shuffles the row and picks 30%, okay, randomly. So this is the parameter for that, okay. So there are just new two parameters, okay. And this one is input and output data, okay, x and y. And then let's come to this part, okay. uh, I hope it's not too late for you guys. If you have any problem or sorry, any questions, or you can ask in between, okay. If you haven't understand anything in this random set or test size, okay, then you can unmute and ask, don't hesitate. Let's come to now the left side of the equation, okay, equals to, what it does is, uh, as we mentioned that the output and input are different, okay, x and y. So sorry. So what it does is, it let's consider just input x as 4 columns and y as 1 column, okay, the last column. And so now this split does is, it splits x into 2 parts, and it splits y into 2 parts, okay. So there are total 4 parts, for x for the training data. First it splits training and testing, okay. From x contains 500 rows and 4 columns, right? So from x, it contains 30% for testing, x testing, and remaining 70% for x training, right? Similarly for y as well, it divides the y, which is the last column. It divides the last column into 2 parts, y training, which is 70%, and y testing, which is 30%, okay. So total we have 4 parts, okay. So this x test and y test will be used for testing, and this x train and y train will be used for training, okay. All right. So we will just run it, and then the data is each time, as I mentioned, whenever we run, it picks up randomly, okay. So each time when we rerun this cells, these variables will contain different data, okay. It would not be the same, would be the same as previous one. It would still divide data in 4, okay, 4 parts, but it would be random order, not the same order, okay. So we have run it. Now we have splitted it. Now the it's time to train our model, right? So for training, we have data on our hand. We need to train model, but where is the model? We have to import the model, okay. As I mentioned that there is scikit-learn, and it has already architected the model, because all the time it would be same, and we can use that to adopt our data, okay. We do not need to uh, create the linear regression model from scratch. It is already built, okay. The model is built because it is very generic. What our main steps are, actually the 80% of the time we spend is on this data, with playing with data and splitting, and if it is not refined, then refining them, the data and all, okay. So let's just train our model, okay. For training we need model, so we will import the model, the inbuilt model, okay, which was already defined, okay. The architecture was already defined, because all the time it would be same. So as I mentioned here, like from whole package, okay, we only need this one. Okay, so we imported that one. So similarly here also, it contains many it contains many models, okay, in scikit-learn, and inside that there are many models. uh, Inside scikit-learn there are many models, okay. So one of them is linear models, okay, but inside that linear model there are many linear models as well, okay. So from there we need the linear regression model, okay. There are multiple other linear models as well. You will yeah, you can refer them on the internet or read about them, okay. We would not like cover all of the things in all the detail, okay. We will just we will cover all the necessary stuff which are like enough for you to start your journey, okay, in the ML. So we will need only linear model, sorry, linear regression model, okay. So we can use it by linear regression. So from those folders, just we need this linear regression. So we just imported that. Okay. Then let's like we need to refer it again and again, right? As we refer to it as like pandas, but no need to refer it. What we are doing is this is a method. Okay. This one is a method. All those are methods. As we have used here, trend test split. This was the method. Trend, trend test split and then the round basis. So similarly, it is also a method. Okay. So what we will do is we will create an instance. Okay. Regression. Yeah. Linear regression. This one, what this does is it is a method. Okay. It calls the method. Okay, and brings the model. What we are doing here is we call the method. We pass the parameters. Okay, and it bring the required things. Okay, and we assign them into the variables so we can refer it again. Here what we are doing is we are calling this function, and in this case we do not have any parameters. Why? Because we do not have to specify anything now, okay, because the architecture is already defined. So we just calling it, and we are what it will return is required thing, which is model, okay. So here we named it accordingly so we can refer it better, okay. So here I am using model, okay. The model here is just a parameter name, sorry, the variable name. You can name it anything, but what it stores is the model written by this method, okay, which is linear regression model. The architecture of the model is written in this variable, okay. So now we can refer the model with the model variable, okay. It can be like sounding confusing, but if we say that my model, okay, my model, okay. So now what it does is this method returns a model, a linear regression model, and then we are referring that model with the name my model, okay. So let's keep it my model, or just model. Let's keep it my model. All right. Then we have bring the model on the table, okay. We have bring the data on the table. We have splitted the data. Splitting is a necessary step here, okay. Now we need to feed the data to this model, okay. Now as I mentioned that this model, the written model in my model, okay, is generic. It can be used for any data. It can be used for any data now, but as soon as we train the model, we feed the data to the model, it becomes specific. So now what we will do is we will feed the data, okay. Or in other words, what we can say is we will take this model and we try to fit this model to our data, okay. Like this is the same thing, feeding data to the model or making the model fit into our data. The thing is same, but the like whatever you get, you can refer it because the concept is like same. uh, both things are same. You can refer the concept anyways, but that is the same thing. You can say that the model is being fit to the data set, or you can in other, because that is a that is a better terminology to use. The model, as I mentioned, it is generic. We want to fit the model into our data, okay. And in layman's terms, what we say is we are feeding the data to model. Basically it's the same, but we can refer it anyways, okay. So let's do that, okay. We will refer this model by my model. Then we have method for that as well, as we have method here. Okay, test and split we can use, as we have referred like use this now this one. It brings all the related methods we can use for this. Okay, with this model. So we can use this fit model. What we are doing is specifying the name of the model which we have assigned, and then the fit method. Okay, so now we want to fit the data, or we want the model to be fit into the data. Okay, so model dot fit, and then we will pass the data. Which data? The training data, because now we are doing the training. X train comma y train. Yeah, that's it. Okay, so as soon as we run this, what happened? My model is not defined. Okay, I just forgot to run this cell. Okay, so that's it. Okay, we are passing the data, the training data to the model. Okay, now um as you can see, like this linear regression model is very simple. Okay, it is just an equation of line. Okay, y equals to mx plus c. Okay, now instead of mx it can be like more things. Okay, mx1, mx2. Okay, m1x1, m1x2, m2, sorry, m2x2. I think if it is clear till now, then we can move further, and then like if you have any question now, so please ask now, or else like this is it. Like we have bring the data. Okay, we have treated the data, we have bring the model. Now we feed the data into model, or we feed the model to the data. Okay, so we have done this. The model is now trained. Okay, the model is now trained. um, by this step. Okay, as we fit it, okay, fit the model to data. This is called training. Here what we are doing is training. Okay, this was this was performed very quickly, because it is very simple, and our data is not much. We only have 500 rows. So it is now the model, my model is now trained. Okay, it is now it have become specific now. Okay, we cannot use this model again. Okay, it contains like it is now become specific to the data we fed. Okay, for the data of customers. So let's before moving on, let's see a simple what you can say simple concept. Okay, the linear regression is simply a line. Okay, to the data. Sorry. Yeah. Okay, these are let's consider these are data, and this is a line. Okay, passing through the data. And what like what was I telling? Yeah. We know that what is the equation of line. Okay, model is just mathematical representation of the line. Okay, so that is mx y equals to mx plus c, right? I hope it's visible. Yeah, it's visible. So we know that this line can be see, one more concept is that this is the equation of line. Okay, and here we have only one x, right? We have only one x, one y in this case. Okay, this is let's just clear out the theory. Okay, here what we have, one dependent variable, one independent variable. Okay, and these two, m and c, are constants. Okay, constants you can say, or coefficients. Okay, anything, but they are constant terms. Okay, now what we have is, in our case, we had uh, y sorry, we had 1y. Okay, the last column, which was let's say, let's see it. Okay, data dot head, which was the amount. Okay, total amount spent. Okay, so with like we are having one y. Okay, one column in y, and four columns in this x. Okay, four columns. Okay, let's say four columns here. So how this line was drawn? Like y equals uh, m, okay, x1, okay, x2, comma x3, comma x4, and sorry, for each of the term there were just a moment, let's delete it, m1 x1, yeah, plus m2 x2 plus m3 x3 plus m4 x4, okay, plus for c, what we were having, let's consider it 0 or something, okay. So we are having this one parameter, okay, in the output, and we were having 4 inputs in the row, okay, 4 parameters for the input, this all 4 things, right? So how the line was drawn is using this equation, okay. So there is y, okay, and this is still a what you can say, this is still a linear line, okay, this is still a linear regression or a linear line. There are no exponentials, okay. So it we can draw a line using these equations as well. Actually the line was drawn, or the linear regression, which is basically the line, is using this equation, okay. There are one output, okay, and 4 independent parameters and one dependent parameter, okay. So there are no squares, okay. These numbers can be looking larger than the independent variables, but all of them have 1 degree, okay. So basically this line, this whole equation is a equation of linear line, okay. So what we had is, we had y, we had x, x1 x2 x3 x4, okay. While training we were knowing this y, okay, because linear regression is a supervised algorithm, so we were knowing y, and what we were doing is, we were just trying to find this m, okay. We were trying to find this m1 m2 m3 m4, okay. Now why we were finding this m1 and m2 and m3 and m4? Why? Because we were actually finding the relationship between, if you consider that only, like just consider zero constant, okay, and if you want to find a relationships between y and x, what is showing the relationships here? The m, right? The m, this is showing the relationship, okay, between x and y. So similarly for 4 parameters there are 4 coefficients. You can like consider it, tell it as a coefficient. Actually we refer to it as a coefficients, okay. So there were 4 coefficients because there were 4 independent variables, okay, independent variables which were having some value, which we know, okay, which we already were knowing, okay. So what we were finding is, we were in at training stage, we were knowing this y, we were knowing this all 4 x's, okay, for x1 x2 x3 x4, we were knowing all that. We were just finding m1 m2 m3 and m4, okay. So basically finding relationships means finding the value of m1 m2 m3 m4, okay. So now as we trained, okay, as we trained, what it did is, just for an example, this is 2, okay, sorry, let's consider, uh, here it's 4, okay. 4 equals sum x, not x, let's say p, okay, times 2, okay. Let's consider, we have outcome 4 and we have input 2, okay. And here sorry, yeah, we have this equation, okay. 4 equals to p, and then this some sign, okay. Here as we know, like m1 into x, right, m and into x, so there is a multiplication, or you can just remove it as well, okay. So this one is m, uh, sorry, yeah, this one is y, okay, in dependent variable. This one is x. We know these two things. We were finding p, and how we find this? We tried with like all possible things, okay. Like first we tried p equals to 0, okay. So does that satisfy our outcome? Is 2 times 0 equals to 4? No. Now we know that if we are considering p equals to 0, then it would not give a proper answer, right? Then what we did is we tried p equals to 1. Okay, so is it giving me proper output? No, still not, because 2 times 1 equals to 2. It's not equals to 4. So then it changed its value to p equals to 2. Then it found that, yeah, this satisfies the answer. Okay, so this can be the possible value of p. Okay, this can be a possible value of p, right? So like that, here what we are doing is we are finding the value of p. Similarly, we are finding the value of m here. Okay, the same thing. Okay, but there can be other approaches as well. Like here, what I did is I did try all the all the possibilities, like from 0 to 1. I If it was said as a if the actual value of p were around 100, then where how how much time it would get. Okay, so we are finding p, but not in this way. Okay, this is just for explanation. Okay, actually what happens is it just try to predict the value of p. Okay, this does not try all the possibilities. Okay, because that would be a too much time consuming. Okay, so it just guesses, or on the basis of here we can just see and answer that it should be 2. Okay, without going through 0 and 1. Similarly, what it does is it tries to guess this p. Okay, which can be either true or false. Okay, uh, if the value would have suppose 8. Okay, so computer might think that it should be around p should be around 3, 4, or 5 something. Okay, this just guesses it. Okay, it does not actually calculate all the way, because there would be no point of that. Okay, then it would become a simple algorithm. Okay, but what in machine learning it happens is it guesses the p. Okay, then it tells us that okay, the value of p should be this. Okay, uh, hello, yeah. I'm sorry if anyone is speaking anything. Is there anyone having doubt, or I think it's too late today. So let's quickly finish it. Okay, so what it does is it just try to get the value of p. Okay, so in training it tries to find value of p. Okay, so here we did the training. Okay, till now we did the training here. Okay, training. And then what it did is it tried to find the value of this m values. Okay, m1, m2, m3, m4. And what we got the value of m, those m's are, we can see the those values by using my model. Then just a moment, guys. Alright. Yeah, so we can see that m values using my model dot dot coefficients. Okay, so you can just you use you will have to remember this, or not remember. Yeah, this one, coefficient. Okay, this stands for coefficients, and what it will do is it will show the it will return the coefficients. Okay, coefficients means this m values. Okay, here this which were responsible for the output. Okay, so here you can see that this brings the 4 values, right, in a list. Okay, array. This is a numpy array. Okay, this is a numpy array which we have written. Just as you can see, these 4 values. Okay, these 4 values are the values of this m1, m2, m3, and m4. Okay, okay, all these are all 4 those values of m. And now we got these coefficients. Okay, so we got the value of m. Okay, so let me write once again. Y equals m x plus c. Okay, so now just get rid of the c. Okay, we don't need c, because c can be any constant. Okay, it does not depend on any like this x. Okay, so without c, it also it is still a linear equation of linear line or linear regression model. Okay, so now what happened is, now as we can see here that we got the values of m. Okay, we got the values of m. Now we know y, we know m, we know x. Okay, and we found out m, value of m. Okay, this is just for explanation. Okay, we found the value of m. Now what we can do is, for this was for training data. Okay, for all the training data we found y, we were knowing y and we were knowing x, we found the value of m for training data. Now what we want to do is, we want to use this model. Now it is trained model. Okay, now what we want to do is, we know this m, okay, as we found, and we will pick one value from testing data. What we will do, we will pick one value from testing data. Means we will be knowing this x. Okay, and this m value which we got after training, we will use that value. Okay, now we will use that value. So now we have two values. Okay, and we do not know, like we want the model to predict it. Okay, so now like mathematically it's simple, right? We know m, we know x, we multiply it, and whatever is the outcome, that is the predicted value. So now if we ask model, or if we pass a training data. Okay, we are now passing a training data. We are passing x, which we know, we have m, which we have just found, and we will we will ask the model to predict it. Suppose it predicted 4, sorry, suppose it predicted 6. Okay, suppose it predicted 6, and the x which we were knowing from testing data was 2. Okay, and the same model was here used. Okay, so now like we got some idea that okay, let's say this was 3. Okay, yeah, after training this, okay, we found the model guessed the while training, the model guessed that the p should be 3. Okay, for this case. Okay, now while training we passed the 2. Okay, and we passed the m which we found. Okay, and we tried to predict y. Okay, so what we got is 6. Okay, now you can see that actually the model predicted the answer to be 6. Okay, but we know that we were knowing actually that while training, in test data, the 2 refers to with 4. Okay, 4, or okay, let's consider 4. Okay, or like just consider it. Okay, the the 2 should answer 8. Okay, so now the model is answering 6, but the answer should be 8. Okay, the answer should be 8, but it was predicting 6. So we know that there is some problem. Okay, there is some error in predicting. Okay, so what we will do is, we will again train. Okay, we will find that is it accurate. Okay, so 6 times, like what we can say, it did it made an error, right? It made an error, and now we want to correct it. Okay, so we again train, like again, before training we check this kind of cases so many times. Okay, so many times, like we had 30% of data in testing. Okay, so we test all the data, that what it is predicting, and we see that is it predicting right one, okay, or not. If it is not predicting right one, then we can decide that it is not like properly trained, we need to train it again. Okay, but if it outputs 8, okay, uh, like just consider that we again trained it. Okay, it didn't give the output properly for like for most of the test data, it didn't give it output properly, right? So now we decided to train it again. Okay, with more iterations. Okay, we will see iterations like more times. Okay, again and again. So what it did is, it did this kind of thing. Before it it was predicted 3. Okay, this 3 was just guessed by it. Okay, but now we check this, that this is 6 and this is 8. Okay, so it predicted less. Okay, than the required one, it predicted less. So what we will do is, we will find that the error was negative. Okay, error was negative, so because the predicted value was less. Okay, but the predicted and the actual values was higher. So we will give it that you predicted less than the actual output. Okay, so what it will do is it will try to guess a higher number. Okay, next time when we train it again, what it will do is it will try to guess a higher number. So what it will do is it will now guess the m value like 4. So now what we again, like after testing, what it did is it ended up with 4. Okay, the value of m. And now this is updated, then again we will test it that now at this time what is like, is the m correct or not. So again we will check it. Okay, so again we will pass 2, and now it will predict it. So now we concluded that it predicted the right answer. Okay, so that is how the iteration goes. Okay, if it doesn't output a right answer, then we again um, try to change or train it. Okay, so this happens in training phase. Okay, this all things happens in training phase, because in training phase these are like what we can say sorry, this is a combination of training and testing. Okay, first in training phase, the only prediction of m value is found. Okay, which we seen here. Okay, the value of m is found. Okay, then we will see the testing as well. Okay, we will move on the testing, right? Let's see, we have seen the find the value of m. Now how we test. Okay, so as I mentioned that we would be knowing input x, we would be knowing m, which is like just found out, and we will try to predict y and then compare it with the actual y. Okay, with the actual output. So we can do that using this. Now like what we are doing is just giving the input x and asking it that predict. So similarly we can do that by my model predict. Okay, my model and then dot predict. So what it does it we have to pass the x as we mentioned, and it will use m from the previous one because it is already trained, right? So what we are doing is x sorry x test. Now we will pass test data. Okay, now we are doing testing that whatever we have in test, it will use m values from here and this x data. Okay, the value of the input data for testing. So it will try to predict the outcomes of for this testing. Okay, so let's run it. So it predicted. Okay, so we will just save it in the some like let's say prediction. Okay, prediction equals this. So now all the predicted values are stored in the predictions. Okay, now what we want to do is we want to compare. Okay, this one and this are containing predictions, and we know that y test contains the actual outputs, right? We have seen that y test contains the actual outputs. So we will compare this y test with predicted values. Okay, so how we will do that? We will do it using a graph. Okay, so through graph we can see it clearly. Okay, that let's say we will use matplotlib here. Okay, and try to do scattered graph. Okay, because it would be like easier to see like what are the differences. Okay, we use t test and I'm sorry, yeah, y test. Sorry, not t test, y test and against predictions, right? So on the x-axis, there would be y test the actual outputs, and on the y-axis the predicted outputs, right? So just name it as well dot x label. I'm using this matplotlib to just to what we can say just do not forget about matplotlib. Okay, because there is c1, but matplotlib is also gives us a more control over the plots. Okay, if you want to change any labels other than the name of column. Okay, predicted y. So let's plot the graph. Plot is not defined. Okay, I just forgot to import the matplotlib. No, I did that. Let's do it again. No problem. Import matplotlib as Python. Let's run it. Then yeah. Now you can see that like this is a linear graph, right? What it shows is uh, at 300. Okay, at 300, the y actual output was 300, but predicted output was something around like the more you can see that for 300, the prediction is, if the prediction is 300, then it is good, right? For 500, if the prediction is 5, then it is good. But if it varies, but if all the output predicted output was same, then there should be only a single dots, right? But there are little little differences, right? Through the positions. So what we can see is, if the these predictions and tests are like linear, then the predicted values were much more like accurate, right? The predictions were much more accurate. It should be 500, then it was 500, right? So using this graph, we can see that the predicted values was very similar to the y values, the actual values, right? So using this, you can see that. And what happened is, we just tested it. Okay, this was for testing. This was for testing data. Okay. Uh, Now what happens is that the testing data was not known. Okay, so that's why there are little changes. Okay, but if we try to draw the graph against the training, then it would be like a proper line. Okay, so this is how you can see that the wide test or this testing data was not fit. Still, the model was able to predict the output. Okay, and they were like very close to the actual outputs, right? Because if they were very close, then 400 would have something around like 600, but it is very near to 400. Okay, so you can see that this is basically a visualization of how much the accurate the prediction the model is making the predictions. Okay, then there are other ways of checking that is the model is performing well or not. Okay, so there are other as you can see that there are like some differences, right, in the testing. So what we can do is now we can also find the specific changes. Okay, that how much it is varying. Okay, it should be, if it should be 600, then how much the value is varying. Okay, if it is 598, then we can say that the value difference is of 2, right? Because that would be helpful for retraining the model, right? So we can evaluate the model, the current model, using that this there are few other matrices which are called evolution metrics. Okay, which can be imported from scikit-learn. Okay, and we can use those metrics to actually see the numerical values of differences. Okay, we can see it in the graph. Okay, but if you want to check the numerical values, that what exactly is the difference, okay, then we can do that. It is basically known as evolution. Okay, now our model is trained. Okay, our model is also tested. Now we want to evaluate the testing part, like how model perform while testing, while we test it. Okay, so we can do that by like just let me go through few statements. Okay, I will tell you what it is. And yeah, uh, metrics dot mean absolute error between y test and predictions. And similarly, copy outside. Yes. Printing. Okay. Yeah. Just a moment, guys. I will go through all of this. Okay. Yeah. So the first one is mean absolute error. Okay. If you have studied this in theoretical part, then you might be knowing that the mean absolute error means the error, like the difference of all the points, and then their mean. Okay. And like finding their mean, that will result in mean absolute square. Okay. Then another one is mean squared error. I know that today's session is quite like lengthy, but not lengthy actually, but like for getting all the concepts side by side implementing, uh, it had taken time, much time. Okay. And then numpy dot square root. Okay. So let's see. Numpy dot square root. Yeah. So what we are doing here is, let's go one by one. Okay. We are passing it. Let's first see this method. Okay. On this method, mean absolute error. Okay. Mean absolute error is like a mathematical function. Okay. Where we find the difference of two values, and there are multiple pair of values. We find the difference between all of them, and then find the mean, means average of that value. Okay. So we will see that we have pair of values like y test, which is actual output, and the predicted output. Okay. So what we are doing here is, we are finding the difference between predicted value and actual output, and taking their mean absolute square. Okay. And we are using this dot matrix for, like, as we have used it for other, like pd dot data frame and all, right? To use this function. Okay. To use this function, we have used this matrices. It is similar, like it is an also a sub part of the library scikit-learn. Okay. We have to import it because it allows us to perform matrix operations. Okay. Because this white test and predictions are in matrix format, like in a tabular format. Okay. uh, so we need this matrix library here to deal with the tabular data and calculating on tabular data. Okay. So what we are printing is here is, first is MAE, means mean absolute square, then mean square error, and at last square of mean square error. Okay. Root mean square error, also known as root mean square error, which is just the square root of this mean absolute square. Okay. Let's run it. And yeah, what happened? Scikit-learn met prices has not able to mean square error. What happened? Square error.
There
Yeah.
is a D in mean square.
Yeah, yeah. Got it. Mean square error and numpy. Okay. All right. We need to perform square root. We need numpy library, which is numerical Python library. Okay. Import numpy as np. Oh, sorry. Yeah. Now we can see that these are just we are performing the mathematical operation to see the errors. Okay. Like there are different ways of seeing the error. The one is absolute mean of differences. The second one is the squares of all the differences. Okay. And then finding its mean, and mean is average, and the last one is mean absolute error and its square root. Okay. So this is how we are finding the values. Like this is the mathematical values which are representing the differences between the predicted values and the actual values. Okay. Then what I think that's pretty much it. Like we have trained the model, okay, we have splitted the data, we have trained the model, we have made predictions, okay, and then tested it as well, like what is the like is it our model is predicting like proper outcomes or not, and then we also evaluated them, so we find very less errors, right? The mean absolute error is very less. So I think we can conclude that basically that the model is trained properly because it is giving us better results. Okay, it can be more better, but this is acceptable. Okay, we can again retrain it. Okay, with repetition. Like if we train the model again and again with the same data also, and if different data also, like if you are feeding it the same data again and again, if you run the training cell again and again, then it will like fit into the training data more and more into the train data. But there are some consequences of doing that as well, because we know that as much as we are training, the model adopts the data more, okay, but there is a like a downside of that is it performs like it does not perform well on testing time. Okay, if we there are concepts like overfitting and underfitting. Okay, so if we feed the data again and again so many times, then it becomes overfit. Okay, the model is known as overfitted. Okay, so there are consequences. So this time we just see the workflow model. Okay, and at last we you might have seen the residuals, right, which is like same thing for you seeing the errors, or for seeing the differences. Okay, so we have let's just draw this residuals. You might have else we will do it later time. Okay, it's quite late. Okay, uh, we will see that in other models. Okay, this is it, and if we from here only, this was like we predicted that now the model is proper. Okay, so now what means is this values the coefficient of the m here. Sorry, yeah, here now after training the m's are like proper. Okay, and means if and for the testing it is giving a proper output, that means the m can be trusted now to predict to actually predict. Okay, so to actually predict means passing, instead of test data, we have to pass the inputs, actual inputs which we want to predict. Okay, so that is the same thing. If you want to use this model now, so you just have to use this my model dot predict and then give the inputs. Okay, and it will predict your outputs. So for using, you can use this. Okay, but as we have evaluated the model, we know that the model is properly trained. So means these values are what we can say useful. Okay, these values are trustworthy. Okay, we can trust these values, means the actual model or actual data is according to this coefficients. Okay, so these coefficients are well uh, correlated with the data, so that's why it is the model is able to give us the proper output. But one thing, just if we go back to our main question, our question was where to put our efforts. Okay, so I said that to do that, to find out the where to spend our effort, what we did is we find the relationship. Okay, and we seen that where to which one is more correlated with spending amount and which one is less correlated with spending amount. Okay, so that does mean that if some parameter is more related to spending amount, then means that parameter is more contributing to the spending amount. Okay, so it is more contributing to the revenue. So we want to work on that app or website which is less contributing, so it can contribute more. Okay, so we need to put effort more where there are less customers coming from. Okay, so as you have seen it, just let me draw one. I will be using this for m values. Okay, and these 4 m values are basically, if you see the first m value is for the first one, okay, the session length, okay. So means uh, after seeing these values 25, 38, 0.19 and 61, you can say that the length of membership is like the most influential in these 4 parameters, and this one is least influential, this one is moderate, and this one is also less. So this 4, let's map it down. All right. It now only take 5 minutes. Okay. Let's say coefficients. Just use okay. Coefficients equals pd dot data frame. What I am doing is just creating a data frame which shows in a tabular format all the parameters and sorry, all the coefficients and the column values. Okay. So it was my model dot coefficients and columns. Okay. Next dot columns, and the column name should be uh, just moment. Equals, okay, yeah, coefficient, and just show. So it just it just shows that all those 4 values with the with these parameters. Okay, like it is just showing that the these parameters are influential this much. Okay, so if the value is 1, then it is directly proportional. Okay, it's 100% correlated. Okay, we have seen this in graphs, I think. Okay, so 1 represents that um, 100% surety. Okay, 1 represents 100% surety that they are directly related. Okay, correlated. Then from this data, from this much data, the values of coefficients, what we can conclude is this one is the most influential. Okay, this one contributes the most in deciding how much amount the customer would spend. Okay, and this one sorry, this one, what can you do? This one is contributing less. Okay, the website is contributing less because so many people goes on the website, but they do not spend any money that much. So it is like from the this for it is very not that much, or it is not contributing to the revenue, actual revenue, but this parameter is like more related. Okay, and the session is length is also related or contributing to the in deciding how many amount it would spend, because 25% as the session length increases, then the amount spent also increases. Okay, but that is not the case with websites, because there are number of users are higher. So from here, what we can conclude that how we can solve our question is, um, through the website there are less chances of getting the revenue, or there are less revenue generated from website, and there are more like this actually what this time on website is less contributing in deciding that what amount will be spent by user. Okay, and time on app is more contributing in deciding that how much amount is going to be spent by the user. Okay, so we can answer our question that if the like in deciding what is contributing what is contributing in deciding how much amount the user is going to spend. If you want to do not want to like target large audience, then we will focus on only app, because that is giving us more value. Like there are more people or more time on app, then that means more revenue, right? So we will focus on that. Or if we are trying to increase what you can say revenue from all the steps, then we might go for website improvement, right? So we accordingly we can focus our efforts on website. And through this data we can decide on where to spend our efforts in improvement. Okay, so that was the end of the through this data. Okay, through this coefficients, what we just did after finding this coefficient is that we just clarified that these coefficients are right, or are actually not giving us error. Okay, so we just found out that these coefficients are accurate, and then if they are accurate, as we have seen here, the error is quite less. So we can conclude or make decision on this coefficients, okay, on this data. So here you can see if someone is asking that if I want to bring people or bring customer from all the streams, and I want to make revenue from all the streams or all the platforms, then where should I focus on my efforts? Then people will say on the basis of this data, that we can answer the question that your revenue from app is good, but from website it is not good. So if you want to bring people from all the all the platforms, then you should work on website. Okay, but if the question is I want to save my resources, and I do not want to waste my resources, so where should I spend my resources? Okay, so where should I spend my efforts? So in that case, we can what we can conclude through this data, that your revenue is majorly consisting from apps, okay, and not from the website. So you can only focus on apps, okay, you do not consider website, so your resources will be saved, because 38% of the efforts or resources gone into app have made the contribution in creating the revenue. So likewise we can make the decisions through the data. Okay, so that was it for today. If there are any questions or any doubts regarding whole of this, I know I have taken much more time today than usual. I'm really sorry for that, but uh, like that was the only way I could explain all the things and relate all the things. Yeah. If there is any question, then please feel free to ask. You can unmute your mic, or as we have done with today's session. We will try to start tomorrow's session early, so you don't need to wait too long. Okay. So is there any doubt from today's session? Then please ask. I'm here to answer, and else we are done today's session. Please go on.
I had one question.
Yeah, sure. Go on.
For this model, we did not scale the X values, right? Still, we got a high accuracy. How was that possible?
Yeah, we did not. You are trying to say that we
The
didn't.
mean max scaling 0 to 1.
Yeah, the mean max. Just okay. I think okay. Your question is that we only trained one time, and it gave the accurate answers, right?
No, 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 no. I am talking about our X values. They are not between 0 and 1, right? They are between some.
Yeah. Okay.
They are large values.
These values are bigger values.
Exactly.
Yeah.
Sometimes we divide them using the formula. Na? There is minimum minus maximum.
Yeah, I got your questions. Like we convert all these numerical values in the range of 0 to 1.
0 to 1, huh?
Yeah, I got your questions. So basically, as I mentioned that this model, okay, this linear regression model, this is actually what we can say the architecture of the model is actually defined like uh, like that it takes care of that. Okay, we do not need to explicitly do scaling and do normalization. Like we do not need to also normalize the data as well. Okay, so what you are telling is a very good question. And like as I mentioned, that this is the architecture of the model is built like that, that all that like necessary steps which we do repeatedly are combined in all together, and we are just using that architecture behind the scenes. Okay. So actually that thing is done uh, in this model. Okay, so actually that model is doing that. Did you get?
Oh,
Yeah. Like when we pass this fit now, this fit method, it takes the values in row. Okay, this x train and y train are containing higher magnitude values. Okay, now, but when we pass these values into the fit, okay, using fit method, when you uh, pass those data to the model, it performs certain operations, and then the values, actual values, are stored there. So this is a method, and inside that method, like you do like those steps are already defined there. Okay, so you do not need to do it explicitly. Yeah, nice question, by the way. Nice observation. Yeah. Any other questions regarding this, or did you understand what is happening here?
yeah, I
Uh,
have understood this one actually.
so any other questions from anyone else? Uh, if there is no question, then I think we are done with today's session. Please feel free to ask if anything is not understood. Like then I'll say there is no point like spending 2 hours, right? So please feel free to ask if there is any question or you haven't understand any single point. Okay. So, or else I can also refer to you some materials there where you can get like more detailed understanding of the topic as well. So if you want to like check or if you didn't get any specific point here, then please feel free to ask. Like don't keep it to yourself and don't hesitate. I think if there is no question, then we are good to end our session. So just keep a thumbs up if nobody have doubt, or if someone have doubt, then please unmute and ask. Okay. Okay, I think yeah, we are only 4 people are left here, so no problem.
Uh,
Yeah, let me stop the recording.